All right. It's great to see everybody. I know we've seen a lot of each other over the past 12, 14 days, but I can't believe we're all still here journeying through Lightship together. And today we have a really great session focused on Lightship Semantics, which I'll get to here in a second. And so if you were having trouble with them, if you were waiting for to understand kind of the direction we're going or learn some of the best practices, you're going to hear that stuff today, and you get to understand a little bit about how it all works. And so before we jump in there, I want to chat a little bit about what's happening in our community. One, if you found yourself here but didn't realize the templates challenge was going on, now you know we have a templates challenge. It's one of our easiest learning resources where you pull in a template to your Unity scene, replace the assets as you would like to customize the template, and then publish to your phone to test. So we've got a challenge going on to get people utilizing templates, learning how to use them, and really making quick quality builds. So that lasts for another 2 days. We just finished up 10 days of templates where we held a workshop every single day. Some of those workshops are now online, and there's a playlist called the Templates Challenge playlist. And so if you didn't get to attend those workshops, check those out. You can still get one of the templates in by the deadline, which is midday Thursday, midday for us here in California, in America. And then lastly, along with the cash like prizes that are associated with the challenge, there's this really cool piece of the challenge that's kind of community driven. And that's we're looking to hit a milestone of 100 submissions from our community. And if we hit that milestone, every single person who submitted, whether you win or whether you don't win, everyone who submitted is going to get access to a private metaverse session with John Henke, where he talks about the vision for the metaverse here at Niantic and what he thinks that's going to look like. And then also we will open it up for Q&A, so you'll actually get to interact with him. So again, John Henke founded Google Maps. He founded Pokemon Go, he founded Niantic, all those things, and now has created Lightship, which we're all developing on today. But without further ado, I want to introduce our speakers today. So we have Justin and we have Saki, who are here to chat with us about Lightship Semantics. And I've gotten to work with them a few times. Justin actually spun up a lot of our tutorials when we first kicked off Lightship, and a lot of those are included in the documentation and on our YouTube. So he's one to thank for that. And then Saki, we just started getting to know each other and has already come out guns blazing with all the great information of what's coming down the road for semantics. So without further ado, I want to pass it off to them. And I think, Justin, that you're going to be sharing screen today. Is that right? Awesome. Okay.
Yeah, sure. I'll try. So I'll get that started. And then let's do a slideshow. Right. So yeah, let's start by introducing ourselves. Saki, do you want to go first?
Sure. Yeah. A lot of text, but the main point is I'm a machine learning engineer in the AR research team at Niantic. I mostly look after productionizing research, so basically the cool stuff that's in the computer vision and machine learning literature, and translating that into features for the ARDK that can perform on device and for all of our Lightship and Niantic users. I've been involved with the kind of deployment and development of the depth estimation and the semantic segmentation and meshing and so on within the ARDK. So been at Niantic for 3 years and worked on all those key bits. Yeah, Justin, over to you.
And hi, I'm Justin. I've done a bunch of things in my career. I actually started as a games developer and made a whole bunch of games in the PS2 and the original Xbox era, and then became a producer to help deliver more games, and then did a bit of work in film as well, working on various virtual production tools and things to make explosions look cool. And now I've come back around to games again, and I'm at Niantic trying to help us build a really cool ARDK for everyone to use. So that's in general us. So just go to the next one. So Saki, do you want to talk about this slide?
Yeah, so what is semantic segmentation? In general, it's a task in computer vision where it's segmentation, so splitting up the image or an image or a frame of a video into regions based on what's depicted, so the semantic content of that image, What it means specifically in the ARDK is for every pixel in your frame or your image, you get a label for whether an object or a material, which we call a semantic class or a semantic channel, whether that exists or does not. So for every pixel and every class, you get a label of whether you have presence or absence of that object or material. One thing which is notable about the Niantic implementation of semantic segmentation is that each pixel can be more than one thing, which we feel is a closer reflection of reality. So a pixel that depicts ground isn't necessarily just ground, it might be grass as well as ground. And so in the diagram on the left, on the image on the left, we've kind of got different colors showing the different parts of the image and these different segments that correspond to the different areas. And on the right, you can see that playing on a video. Yeah, so at the moment in the ARDK, we have sky, ground, natural ground, artificial ground, water, building, foliage, and grass available. And you can see pretty much all those classes in these images there. And in the documentation, kind of define what we mean by each of those things, since natural ground and artificial ground, for example, can be somewhat non-standard names. If we go next slide, please.
Yeah, there we go.
So how does the semantic segmentation work? It is a neural network under the hood that outputs a probability that ranges from 0 to 1 for each semantic class at every pixel. We do run it on a downscaled image, which is why in the previous slide you kind of saw these upsampling artifacts on the left-hand side. And each of those probabilities from 0 to 1 are thresholded to provide a binary match, so basically just presence or absence. The neural network is trained on data that we capture and label ourselves, and this is driven by use cases. So a lot of this has been driven to date by our internal Niantic use cases, but we're really looking forward to getting more feedback and seeing how external developers use semantic segmentation so we can further tailor the neural network to operate in the situations that people are developing in. And then, you know, one thing that we have to do, which isn't reflected in the academic and research literature, is optimize the neural networks to run on device. So we run a depth estimation neural network and a semantic segmentation neural network. It's quite energy intensive, quite compute intensive, and so we do a lot of work to improve how well it performs on device. So that includes running it at low resolution, like I mentioned, running it every few frames rather than every frame. That's a configurable parameter, and then interpolating between those. And we're working on different ways to kind of help improve that trade-off between performance and the quality or the accuracy of predictions, making those options more easily accessible and tunable by the end developer.
Great. So this next video I'm going to play is the very first thing I did with ARDK a year and a half ago when I started here, which is just make something big in the sky. This is something you can do today. And it's essentially saying, grab the sky mask and render your creatures into it, do some nice blurring on the edges. So it's just an example of the kind of thing that you can build with semantics and a little bit of know-how. And what I'll do in the next slide is just talk you through some of our tutorials and bits of code that help you make something like this yourself. This kind of thing is like, you know, half a day of my time. It's extremely easy to do these kind of things with the APIs that you get. So without further ado, I'll just talk about some stuff. Some of you have probably seen this before if you've worked through any of the tutorials. This is from one of the early ones I made, which is what I call Fetch Quest, which is just basically says, hey, go and find me some water, go and find me some grass, go and find me a tree. And you win the game by getting enough in time limit. So it's probably the simplest game anyone has ever written, because it's 2 timers and a list of things to find. The stuff I wanted to point out really here is there's a nice API in ARDK that just lets you inspect any pixel. So you can basically write a bit of code that says, get the touch point and pass it to this function and ask what's in that particular pixel. And it can give you back a list to say, you know, it's got the ground, but it's artificial ground, or it's dirt, or it's grass, and it can tell you that information, which you can use to make all sorts of fun game mechanics. One being the demo that I'm showing there. So if I go to this tutorial page, which is just on our website already, the area of this that I want to highlight, it's not the standard startup, like you're creating a callback to get semantic buffers, which I'm not going to go into. But what I did want to highlight is there's a function here in section 7 called Debug Semantics App, which is worth looking through, because I've written this to basically say, here is an example of using the majority of the calls that you can ask for in ARDK straight away. So there's, how do I get a list of what channels are in the model? Well, you can do that here and you can print them out. You can either ask for things by index or by string. So what that means is you can say, give me channel 0 or give me channel sky. Each one is mapped. And depending on how you're writing your code, you may want to use numbers to do procedural stuff versus string. So that's why you've got this function here, which is pretty much what I used to build that fetch quest, which is, does channel exist at XY coordinate on the screen sky? So the whole code was just changing what it was looking for based on a random timer. It would just say, currently I'm looking for sky, and then pick another random one every 3 seconds. So this simple function is most of what you need to do that. There are a bunch of other ones that are useful in here. So I'll touch on this a bit later, but because it's per pixel with more than one possible answer for what's in that pixel, it's an integer stored as a binary mask, which essentially you can ask for the whole thing back if you want to do some fancy shader stuff, which we'll talk about later, where you say, give me everything that's in the entire buffer and push that to a shader and these bit masking on it to do fancy effects, if that's what you like to do. And anyway, that's all I really wanted to point out. This is a useful function to dig through at your leisure later, and it's easy enough to build this example following the steps here in the video. The next kind of use case is doing masking. And again, this is just our standard example showing you how to grab the sky texture and scribble in it in a shader. I'm drawing really poor lines here because I've just said use a sine curve to change the color based on time. So that's why it looks awful, but it is augmenting the sky very, very quickly. There are 2 ways to do that in the ARDK. If you're really new to this stuff and shaders are a bit scary, you go to this first one, which is what we call the copy to align functions. What this does is it takes away your need to understand the transforms that are involved in taking the image that comes out of the neural net, which is usually it's a different aspect ratio to the screen, and it's also a different orientation. So it's sort of 90 degrees rotated and not aligned at all. So in the shader version, we just give you a matrix that you can multiply to fix this for you. In the copy to align version, we do all of that for you. So on the CPU, we just return back an aligned screen coordinate aspect ratio corrected image. And that means in your code, when I scroll down here, the only thing that you do is you basically say, catch the event for a new semantic buffer being surfaced, and then you can say, run this copy to aligned. It will return into your texture something that is already set up for Unity, and you can pass that directly into like a 2D screen UI component, like just a raw image overlay. So if all you wanted to do was make something blue, this is the easiest way to do that. And a lot of the samples that you'll see in ARDK are leveraging this because it's easier to understand. The second version of this is actually how this example here works, is using the textures. So this is a little bit more in depth. So if you're familiar with writing textures, this won't bother you, but if you're not, it's quite a jump. The main difference here is it looks very similar in terms of what you get back. It's still returning a texture, but as I said, this texture won't, if you just draw this on the screen, it's going to look really wrong. So you need to also use this transform. This is a standard Unity for, I want a full screen effect or a full screen shader, and I'm saying pass in the texture and also pass in this transform. And then in the shader, there's a little bit of code that we give you here that converts the UVs for you. There's a little bit of math that you have to do in 2 places. So in the vertex buffer, you have to do one conversion using that transform. And then in the frag shader, you need to do another little bit of correction. And then what you've got back here is a normal, it's basically said, sample this weird texture. When I want this point, grab that point over there, and it all magically works on screen. So again, fairly standard first. If you're used to doing this shader stuff, a little bit scary if you're not, but as you learn, you'll be able to do more and more of these things. The third thing that's really useful for this is you can project through Unity standard calls through the camera 2D space to 3D space. So what this video is showing you is if the ball that I throw hits the ground, put something green. If it's not the ground, put something red. You could extend that to be any particular semantic channel you're looking at, do something different. That might be play a different sound. So like water goes splash, dirt makes a thunk, spawn a different effect when a character's walking around. So its footfalls make different kinds of sparks and sounds, all in the real world and all realistically. And this is extremely easy to do, again, with those same APIs where you just say, what is in this pixel? But you have to do it from a camera projection. So what you basically say is, in this case, when the ball hits something, you have a 3D position for that hit, which you can then convert through the camera to say, give me the 2D position of that hit, and then just ask the API, what's at X, Y, and it gives you a list. So what went too far. What I'll show you in here is a tutorial I never got around to porting from a very old version of AIDK to now, which is what that video on the side was showing. So I'm going to skip over a lot of this stuff. But all I really wanted to point out is I have one function in here, fair way down. I'll show you a funny mistake with the thing if it's going to load here first, which is my first attempt at making this work. When the ball hit, it makes a lovely tower of bricks because I didn't turn collision off on the things I was spawning, which meant that it would just launch the ball into the air, which was an interesting side effect of trying to write a tutorial. The bit I did want to show you though is just here. This is the entire function to convert from 3D to not. You basically say camera world to screen point. This is just Unity code. The position, the hit position that you're looking for, that gives you back a 2D point, and then you just say, hey, semantic buffer processor, does the channel exist at X, Y from your converted point, and what you're looking for. So ground, you could also use one of the other functions which says what is at X, Y, and it'll return you a list. So it'll say X, Y contains ground and grass. So useful thing to do. So with that, I'll pass it back to Saki to talk about what's coming next.
Yeah, so probably the most obvious thing is what new classes are we planning to add? So these are new channels, semantic classes that we're working on internally and testing at the moment within Niantic. So there's flower, people, cats and dogs, tree trunks, sand, dirt, screens, furniture, and snow. So these are kind of just what we've got working to various degrees of quality internally, but we're hoping to basically get them out and get more feedback on where they work and where they don't. Yeah, so that's kind of what's coming next. You can see the person segmentation example there, and some of the flowers and tree trunks on the slide. Yeah, what else? So one thing, if you've worked with the semantic segmentation before, then you'll know that there's a couple of issues with it at the moment. One of them is that frame to frame, the neural network output can be inconsistent, which leads to this jittering effect that you can see on screen here, where the predictions aren't stable over time, which is really annoying if if you're doing anything with that mask. We've been working on a bunch of techniques to kind of stabilize these predictions over time. And so you can see the prototype that we've developed internally in the research team, how much better it looks in this particular instance with that stability. So we're hoping to get that out pretty soon. Another aspect is you often get, because we have these binary masks for each semantic class, you get these hard borders between, for example, the sky and not sky, which is the example you see in the bottom there. This just happens because we have this 0-1 binary cutoff. But as I mentioned before, the actual output of the neural network is a floating point value between 0 and 1, and kind of encodes the uncertainty and is quite good about being fuzzy at the edges of of objects or materials. So we've got a prototype internally again, to help improve that by providing and exposing that 0 to 1 value. So for a specific channel, so you might want to do that with Sky or anything that you're masking out. Yeah, and so this would help with the kind of visual screen space effects and software transitions. There is a performance cost to having all of the floating point values, so that's the reason why it's really focusing on doing it only for a specific channel. Anything else to add on that, Justin?
No, I was just going to say use cases for these things is really important. So the first one, the anti-flickering, something that we provide is a holdout for a channel. So you can say the ground is an infinite distance away. So your creature should never occlude on the ground because you don't want their feet to go through the ground. But if the semantic channel we're using to do the holdout is flickery, it means that it only works sometimes. So this stability here means that creatures' feet will look better in general if you use that technique. And there are also a bunch of other useful things to just having a more consistent map. The one on the bottom there with the having the alphaing, the very first video I showed you where I was doing like a box blur to clean up the edges on these boundaries myself, that there's only so much you can do with a blur to try and hide things, whereas this gives you a natural fall off that you could just use these values to be the blur, or running a box blur over this will give you an even better result. So what you're going to see once we get to a point where we can release this is if you've used this already, there's always a little bit of a gap on the edges of our semantics, and this will help you hide it, which is a good thing. Yeah, and that I think is the end. So it's question time.
Yeah, sorry. One thing that I remembered, because you mentioned the occlusion, is that obviously the semantics and the depth can be used together, so you can get the occlusion effect from depth, and then use the semantic output for ground to say, override any depth estimates for the ground and never occlude there. So not only can you do kind of occlusion effects using the semantic channels like Justin showed in his first demo with, placing something in the sky and making it occluded by anything that's not sky. You can also combine it with depth to get more, effects.
Awesome, thank you.
So yeah, questions.
Questions. So how we typically do questions is just like Sergio is demonstrating, raise your hand. If you haven't raised your hand before in Zoom, go down to the reactions, there's a little smiley face, and if you click on the arrow, there's a raise your hand option. I unfortunately have to hop to another meeting. That's the second part of this meeting, but we're going to keep recording so we capture those questions, and you're in good hands with Saki and Justin. I'll see y'all all in the Discord. Bye, y'all.
Great. Sergio, do you want to ask your question?
Hello. First, thanks for this session. Really appreciate it. I have a question. Is possible to get the percent of the channel that we are that we have in the current camera? For example, 30% is sky, 50% is ground, or something like that.
Yep, it's definitely possible. There's no function that says, please return me the percentage of, like we don't provide that as an endpoint, but you can get the buffer and calculate that pretty easily. Like the buffer's tiny, right? Like as Saki was saying, they're very low res. It's something like 192 by 128. So you basically pull it and go loop through it and calculate those numbers.
I'm trying to do it with the number of pixels that have the white color in the current texture. But
yeah, so what you want to do is not return a lot of actual textures. You want to use the API calls. So that function I showed you that's in the demos, which was the debug information app, have a look at that. And what you can do is you can say you can ask what's in every pixel. So you can go for, X is less than the width, Y is less than the height. Give me what's in each of those pixels, and then just sum it, and that'll be very, very quick because it's much, much less than a full texture being returned, and you're not doing like a slow Unity sample texture query. You're doing a very fast. Just is this int? Does this int contain a number? So it'll be much faster.
Okay, got it. Thank you very much.
No worries. Elias.
Hey, Justin.
Eli.
Thank you, Saki. Thank you. Just started last week with the challenge. So newbie here to Niantic. And so I have a very basic question around instantiating based on the semantic or the channel that you touch your finger on your phone. And so if I wanted to instantiate, some fish objects, if I touch on water to make it happen, what script do I find that information that I should do, should I leverage?
Yeah, so that very first example I showed you, which was the one I called fetch quest, or saying, hey, go and find me a piece of grass, that's doing exactly what you were asking for, and that's one of our tutorials. So if you just go to the very first semantics tutorial, and the function it's literally asks what is at XY. So you get the touch point, you give it the XY coordinates, and it'll give you back what's in that pixel. You can also ask the other way around to say, is this pixel water? So you could do it in either direction, depending on the logic that you needed.
Okay, great. And then the second question is related to the channel as to, going back to either triggering the 0 or the 1, what thresholds are you using? And does that vary from channel to channel?
Yeah, that's a great question. It does vary from channel to channel, and we basically have kind of tuned those using kind of our testing data internally. With basically we kind of favor towards having false positives rather than false negatives. So basically we want to avoid the situation where you're looking at something and it's not being detected. We'd rather have the situation where you're not looking at something, but it gets falsely detected. And so the threshold is kind of biased in that direction. It used to be a tunable parameter to the end developer, but it was really complicated to implement. I don't know if it still is, Justin. Yeah,
it's one of those ones that you said it was easier to ship early so you can play with it rather than us trying to resolve how to get that opened up to you. But I think the path that we're taking is the right one, which is we give you optionally for places where you really need the high detail, we'll give you a different call to get that sigmoided, the alpha version of that texture, because that's actually very, very useful for blending and other things.
Great, thank you.
Has anybody else got a question? Because I can't see anybody else with a hand raised. Or Sergio, did you have another question? I just wasn't sure whether your hand's still up or not. Awkward silence. Is there anything you would like us to ramble about? You do have us for a while longer if you want to ask questions. Well, I'll give it an awkward pause for a minute or so, and then maybe we'll be ending early if no one can think of something to ask us.
I mean, the thing is, like, I have one problem. I don't know. So, can I ask one problem? I mean, regarding the semantics, this one templates.
Yeah.
Yeah, I'm using one this one semantics. I mean, segmentations. Like, I mean, combining the both sky and ground, they both not working. Only one segment is working. Yeah.
So yeah, I can't. I don't know your specific problem with the templates themselves. In terms of walking backwards, debugging what's going on, it's really going to come down to what is in your use of that template. So,
okay.
If I'm perfectly honest, I will write stuff from scratch. As you'll see from most of my tutorials, I start from nothing.
Okay, thank you.
I can see your screen. What would you like to highlight?
Like here, I added these segmentation, something like this, and I had another. I created submit this one, something like controller using, making the flaws thing. I tried using the ground also, but yeah. I mean, I can see like these things are working, but the grounds, so segmentation are not working.
I don't know what working is in your example. I assume you're trying to not draw over ground. Is that the case? Or
Yes.
so the first thing I would check, and I don't know if this is what the problem is that mock scene marked up the way you expect it to be? Like, are all the things that are ground labeled as ground? Like, because they may not be. So first of all, check that the mock scene you're testing with is actually marked up the way you expect it to be. And then the other place is the other thing I would do is draw a debug version of the masks themselves, like render just green for one thing and red for something else, so that you can at least see is the thing that I'm assuming the holdout correct or not, and that would help you debug where the problem is. But I can't, off the top of my head, I can't say, oh, it's this, because I don't know.
Yeah, it's fine. Yeah. Thank you.
Yeah, no worries. Has anybody else got a question? Well, I would say that is a resounding awkward silence. So I can probably let you all go and enjoy the rest of your day. Thank you so much for listening to me and Saki rant. And have a great afternoon, morning, evening, whatever time zone you're all in, and enjoy playing with ARDK.